Hi everyone, this is John again with SolidCAM Professor, and I'd like to welcome you to another Getting Started series for iMachining. This one I'll call exercise number 2, iMachining of an enclosure. Now as we perform the programming of an electrical housing, I'm going to cover a lot of good stuff about SolidCAM's iMachining technology. Some of the most common topics in this series that you'll want to know about will include the following. We'll add new machine and material files to the iMachining database. I'll do a quick recap of what I covered in the previous exercise for anyone who's just joining in. I'll also cover the iMachining Technology Wizard and the interface in greater detail. We'll then take a look at using the iRest technology type prior to finishing with iFinish. And I also want to talk specifically about the tool definition and how certain parameters affect iMachining and the Technology Wizard. So let's go ahead and get started. Now, go ahead and launch SOLIDWORKS if it's not already opened. After you have it ready to go, you'll have to then open the part that's provided with this series of videos. The part file for this series is called SCIM Enclosure, and it can be opened directly from our interactive guide. Unless you're otherwise viewing these videos from the SolidCAM website, you have to download the part file and save it to your computer. I would suggest saving it in a preferred location. Once it's downloaded and saved, go to the SOLIDWORKS main menu and click File, Open. From the Open dialog box, browse to the file location and open it. If you're not using the interactive guide, this is how you'll want to open the provided part file. Once the model is on the screen, we can now bring it into SolidCAM for programming. Now in the previous exercise, we customized our CAM settings for these iMachining Getting Started videos. We made sure that our CAM part will be created using the external mode. We also chose the default CNC controller that we'll be using to post G-code. Now, we will verify these CAM setting selections when we start the CAM project and define the CAM part. Before we start a new milling CAM project, let's add new machine and material files to the iMachining database. There are actually 3 different ways you can do this, which I'll point out as we go. Now, let's say you just bought a new machine and you just received the first material shipment from your supplier that you'll be using to make these enclosures. Well, the next thing you should do is add the machine and material to the iMachining database. One way to do that is by going to the SOLIDWORKS main menu. Click SolidCAM iMachining Database. After SolidCAM starts, the iDatabase dialog box appears and enables us to add new and edit existing database files. In the first tab, labeled Machine DB, you'll see that a Haas SS appears in the list. This machine file is included with the installation of SolidCAM. Now it's time to add our machine to the list. And we can do that using the buttons at the bottom left. These buttons give you the ability to manage machine definitions in the list. I'll just quickly go over them. The New button enables you to add new machine files. The Delete button enables you to delete existing machine files from the list. Save As enables you to save the defined machine files under specified names in specified locations. And finally, Revert enables you to return any edited parameters back to their default or last saved values. To start our new machine definition, first click New. When prompted, we have to enter a name for our new machine file. For this example, how about we just call it Haas SS New. Then, click Save to add it to the list. Now in the General area, we can see that there are 3 yellow fields. These fields reflect the machine parameters that are constant and which values are required by the iMachining technology when defining a new machine database file. After finding out these values, let's enter them. So for spindle speed max, enter 12,000 RPM in the input field text box. Enter 21,158 millimeters per minute for feed rate max, G1, and for spindle power max, enter a value of 20 kilowatts. Let's also enter the values for the reposition feed rates. Set the value for XY movements to 10,000 millimeters per minute and the value for Z movements to 3,800 millimeters per minute. Now, one other thing we should do is set the machine default level. In this case, the machining level is the default level assigned to the machine, which reflects the basic machine rigidity and its state of maintenance. The assigned default level is not to be influenced by the speed, power, or acceleration capabilities of the machine. It should only reflect the machine's tendency to develop vibrations. So, for example, an older, ill-maintained, non-rigid machine should be assigned a very low default level, probably between 2 and 4. A brand new, rigidly constructed machine could be assigned a very high default level, between 6 and 8. Now, since our machine is new in this case, let's set the machining level to 6. When choosing this machine for the CAM project, the assigned machining level will be the default level for all iMachining operations of the CAM part. Now, of course, you'll see that you can always change this level on a per operation basis if you feel the cutting conditions are too aggressive for your liking. Now, let's move on to adding a new material file to the iMachining database. First, you have to switch to the Material DB tab. You'll see that there are over 70 materials supplied with the system. However, none of the materials in the list match the material that we just received from our supplier. So to start our new material definition, let's click the New button. For the purpose of this exercise, we've identified the material as aluminum 6061 T6. So that's what we'll enter in the material file name field. Let's now click Save to add the material to the list. In the Material Properties area, there is one required value needed when defining a new material in the iMachining database. Again, this value is represented by the yellow field. For newly added materials, iMachining uses the ultimate tensile strength, or UTS, as the physical property that determines the force per unit area required to cut the material, which is measured in megapascal. Now, the best way to find the correct UTS rating of a specific material is by using www.matweb.com or some similar online resource for acquiring material property data. Let's do that now. Go ahead and launch your browser, and in the address bar, type in www.matweb.com and click Enter to launch it. Then click the Searchable Database of Material Properties link. In the search field, enter aluminum 6061 T6. Click the second entry in the list. Now, in the Mechanical Properties area, we can see that there are numerous UTS ratings based on heat treatment and different temperatures. The iMachining Technology Wizard is totally dependent on the correct UTS value to produce cutting conditions that are optimal. So therefore, it's very important to know the exact specification of your stock material. If there are many entries to choose from, and you're just not sure, or it's just not possible for you to find out the exact specification, you can always start with the highest UTS value. This is absolutely safe. Later, you can decide, based on things like the sound of cutting and rate of tool wear, whether or not it's safe to change to one of the lower UTS values. Now, the higher value may result in gentler cutting than is initially possible, but iMachining gives you the ability to make adjustments on the fly using the machining level slider, which we'll get into later. For this example, I just happen to know that we received a typical supply of 6061 T6. And with that in mind, we should take the first entry of ultimate tensile strength, that is 310 megapascal. Now we can navigate back to SolidWorks and enter 310 megapascal in the required field. And that just about does it. At this point, we can click Save and Exit to confirm our definitions and to close the iDatabase dialog box. I'll end part 1 there, where we just added our first machine and material file to the iMachining database. Now in the next video, we'll have our model on the screen ready to go into SolidCAM for programming. We'll define the CAM part, as well as the machine and material data when we add our first iMachining operation.